Happy Monday morning, pre-algebra. I'm at page 424 in your textbook. Please go ahead and get that out and follow along while I write some stuff up on the screen. As you get it out, listen to this funny joke for today. So, how come all the frogs around here keep dying? Or they're all dead? Why are all the frogs around here dead? It's because they keep croaking. Get it? Got it? Good. All right. Page 424, we are continuing with our rate of change, looking at our y equals problems and finding our rate of change. Today we're going to look at something different, something called proportionality, and then also direct variation. But first thing I want to talk about is describing our rate of change. So when I'm saying rate of change, remember that's finding your differences in the y's, change in y, over your change in x. You remember those problems? You take your second y intercept and you subtract your first y-intercept, and then you take your second x-intercept and subtract your first x-intercept, and you get your rate of change. That means what the change is. But we're going to be talking about how do we describe them. Man, I'm not so good with my words today. Describe a rate of change. So I have three graphs right here, and I'm going to describe them for you. So I'm going to say that this rate of change, we could measure it, but just right now I'm going to say to describe it, it is increasing. And the way we know that is because as our x's increase, so do our y's increase. Both are increasing. However, when we look at this graph, this one is decreasing. It's decreasing because our x's, as they're increasing, but our y's are decreasing. So that would mean that it has the slope is decreasing, the rate is decreasing. Now, we've talked about constant rate of change. This is the same. It's the same number. It's flat. Here, we see something that isn't so constant. It's going to change. We can see as we kind of get right about here in our graph, the slope of this line is very different than this one. This one, it seems to be increasing much faster. As we move along the x-axis, it seems like we really move along on the y-axis. Okay, so we're not going to be looking at graphs that kind of have a curve. They're not constantly increasing. This would be more like accelerating. You're starting out in first gear in your Honda, and then you keep going up, and you get faster and faster. This line would be more like you are just kind of accelerating, but at the same speed. Because typically in your Honda, you start out going pretty fast, and then you can get pretty fast. However, this one might be, increasing at exactly 5 miles per hour every minute. So over a minute, you're increasing the same amount of speed. This one's like you're really pushing the gas, and you are going fast. Okay, so again, that's just describing, but really you're going to be focusing on increasing, decreasing. Those are the two that you're going to focus on for today. So here's the example. I'm looking now at the page 425 at the top. It says a circular design on an internet advertisement has two circles, one that is decreasing in size and one that is increasing in size. Find the constant rate of change for the radius of circle 1 in the graph shown. Then interpret its meanings. So it's asking us to interpret the rate of change for circle 1. So rate of change, remember, we need to do our change in y over our change in x. So it's asking about circle 1. So I'm going to say that our first dot is the one on the left. We're going to kind of, remember, we want to start with our lower x and then go to our bigger x. So you want to start by the dot that's just next to circle 1. So that dot, our y, is 4. Okay, and then our second y would be 5. Okay, and our first x is at 6. minus, we're at 2 seconds for our first spot. So remember, I'm taking the position that our second variable, our second intercepts are right next to circle 1 that's in the little bubble on your graph. It says circle 1. So when I solve this out, I have 1 over, I have negative 1 over 4. So now it wants me to interpret this meaning. So I am moving at a rate of negative 1/4, and I want to say that we are going centimeters per second, because that's our radius. And now we have to figure out our description. Are we increasing or are we decreasing? Does our graph look more like this one or like this one? Well, I'd say it looks more like the second one, so I would say it is decreasing at this rate, at the rate of negative 1/4 centimeters per second. So remember, it's important that we have that negative sign, and really that negative sign means that it is decreasing in a lot of ways. Okay, so that's our first example. We're really looking at describing our rate of change, so increasing or decreasing. So remember, rate of change, we had y2 minus y1 over x2 minus x1. That's our formula that we use, otherwise known as change in y over the change in x. Alright, now let's go flip the page. Or actually, don't flip, at the very bottom. I want to show you something called proportional versus non-proportional. So one thing some of your questions will be asking you is your function proportional or is it non-proportional? So what we're doing is we are comparing our ratios of our intercepts. So as you see here, we're given a bunch of points on a graph. We have 1, 4, 2, 8, and 3, 12. So what we're doing is setting them up as our proportion and kind of like our rate of change. So we're putting our y's on top over our x, but we're not really comparing our rate of change. We're just looking at the proportion. So when we look at proportion, we set it up as y over x. And so proportional means that all of our proportions equal the same. 4 over 1 is 4. 8 over 2 is 4. 12 over 3 is 4. So you would say that this set of numbers and this function and that graph would be proportional. So remember, we're just setting our y's over our x's. So however, when we go down to this next set, it is not the same. It is non-proportional. We have 4 over 1, which is equal to 4. 6 over 2 is equal to 3. And then 8 over 3 is 3 2/3. Or excuse me, 2 2/3. Oh, just erase the whole thing. So 3 goes into 8 twice, and we have 2 left over. I did my math wrong. Okay, all these numbers are different. They have different proportions, so that is non-proportional. So the important thing is taking a bunch of your intercepts and setting them up, y over x, and checking out their proportions. That's proportional compared to non-proportional. Okay, I'm not going to do an example, just moving right along. So now I've turned the page, I'm at 426, and we're looking at something called direct variation. So this kind of goes back to our idea of proportion. We're looking at when something is proportional, we're saying that it has this constant of variation. So direct variation means when the ratio of two variable quantities is constant. So just kind of going back, it has to do with something that is proportional when we're talking about this number that is being constant. So the important thing that we really use is this equation that I have starred right here, y equal kx. And what that means is the k is constant. So we're dealing with something like y equals 2x. Or for example, like in our problem back here, if we found our rate of change, I would do, let's see, 8 minus 4 over 2 minus 1 which equals 4 over 1. So our rate of change would be 4, and we'd say that our equation then would be what? We would say y equals 4x, right? So it's constant. We don't have that plus something. We don't have that. So we don't need to worry about that. That's what we're talking about, is a problem where we just have y equals 4x. Those are the kinds of problems. So for an example, it would be y equals 2x, y equals 4x, y equals 3x, y equals negative 2x. Those are all constants. So on the next page, on 427, you'll see a problem, and it says, the time it takes to burn accounts or amounts of information on a CD varies directly with the amount of information. There's your key word, varies directly. I'm reading right at the top of page 427. So it says, write an equation that relates the amount of information and the time it takes. So we need to use this formula. So all it gives us is our set of x's and y's. Those are our intercepts. So we need to plug it into our equation. So this is really all that we have to do. Since we know that it varies directly, all we need to do is choose one set of variables, of x's and y's, because we know it's the same rate. Just like our last problem, they all equaled 4, they were all proportional. That means the same thing. It's that we can just trust on one of them. So looking at these numbers, the easiest, we're just going to do the first ones, and that's what they do in the book. So we set up our equation, we have y equals kx. So now we're going to plug in our y and x variables. So our first y is 10 equals k, that's what we're trying to find, k times 2.5. Alright, so now I need to get k all by itself, so I have to divide both sides by 2.5. And then I will get 4 equals k. So now I know that our problem is y equals 4x. That's simply all that we need to do, is that we substitute k into our problem. Y equals 4x. Okay, let's. I want to try another one of these. This can be a little bit confusing. So I'm going to do the example. It says guided practice, kind of at the middle of the page. It says unit cost. The graph shows the cost of y of x pounds of apples at the local grocery store. Write an equation that relates cost and weight of the apples. So we're, of course, using our problem y equals kx. And I need to find some x and y intercepts that will work. So the easiest ones that I see would be kind of the one in the middle. We have 1.25 comma 1. So 1 equals the y equals k divided by 1.25. Alright, and I divide both sides by 1.25, 1.25. And I wish I had my calculator, but I have the answers in my book. Ha ha ha. So I know that it equals 0.8 equals k. Now it says to write this as an equation. So instead of y equals kx, I can now write y equals 0.8x. Alright, and it says predict how much 5 pounds of apples would cost. Ooh. So we have to find cost, but we're given the weight. So if you look at your graph, the cost is the y, and then the weight is the x. So I'm going to substitute the x for, because that means weight, so I'm going to put in a variable, or it says to put in 5. So I have 0.5, 0.8 times 5, excuse me. So remember, x's are equal to weight. They gave me the weight, and they want me to find the cost, which are the y values, if you look at the graph. So when I do that, y equals $4. It will cost $4. Okay, so if you have any questions, please ask for help. Otherwise, work hard, and I will see you in real life.